We're getting the volume of the region, and when you bet it's going to be a solid. I'll put that in parentheses. Bounded by that yellow plane right there that we just drew, and all the coordinate planes. These are the coordinate planes. So if you want to know what shape this is, this is bounded on this side, and over here we got that triangle on that side. We got this bottom part down there. See? There's a name for this. It's called a tetrahedron. So you can even reword this problem as we're finding the volume of the tetrahedron formed by this. It's a solid, it's a tetrahedron. A tetrahedron. Now, there's actually 6 different ways we can set up this problem. We're going to do a triple integral. The volume equals triple integral of 1. Now, there's 6 ways you can set this up. You know, dy, dz, dx, dx, dy, dx, change the limits. And when you're okay if I do dz, dy, dx? Okay. Seems an easy way, right? I think it's the easiest way on because, I mean, this is probably the best example. I'm looking at this thing right here. It's a projector, right? Doesn't it just project downward? So you're going to notice in Calc 3 a lot of times, when I have an option, I think it's easiest to project things downward, rather than like to the left or the right, unless you have to. So what we'll do is we're going to project that thing downward, right onto the xy plane. In that case, we're like, all right, then let's put top z, bottom z, and then this is going to be the projection onto the xy plane. And I'll write all that out. What's the top z? It's that yellow circle right there. What's the equation of that? We've got to solve for the z. What would z equal to? 4 minus 8x minus 2y. All right. What's the bottom z? Nice! So the top z is that one, the bottom z is 0. So far so good? Alright. So when taking care of that, that's my top plane, that's my bottom plane. The xy plane is 0. This right here is what we refer to as the projection onto the xy plane. Project this onto the xy plane. What do you get? And when it's this region, I'm going to call it the chalk. Right in here. Does everyone see that's a triangle? This was what, a half? What was this? 2? So I'm going to draw that. I want you to see it. So let's say that's the x-axis, that's the y-axis. Can you help me draw that triangle again? Just to rewrite it, because you might have a hard time seeing that looking down. What does that projection look like? The y value was 2. What was the x value?
Half.
1/2. And I'm going to shade in this triangle. It's a triangle. Can you set up the limits integration for that? Well, this is going to be 0 to 1/2, right? How do I get the equation of that line? Y equals mx plus b. Give me the equation of that line right there, and I can put it right there. It's the equation of that line. By the way, here's the biggest error. I see this all the time in tests. People go, oh, 2 to 0. No, that just made a rectangle, right? What I mean, that's a triangle. This will be 0, but what's the equation of that line? I get y equals rise to run 1/2. What's rise to then run 1/2?
4.
4. So I get 4x plus what's the y-intercept?
Isn't it negative 4?
And it's negative 4x because it's going down, brilliant. So I'll put it right in there. Negative 4x plus 2, or you can write 2x minus 4. Let me make sure this doesn't run into that, so maybe we can get this in notes. 0 to 1/2, negative 4x plus 2. And then you can work out the problem. But this one, I just wanted you to set up. I mean, we will work a triple integral in a second. I thought we could work it out when we found like the mass. Like the mass of the solid. Is that okay with that? Nice. Nice. Hey, we can talk about shortcuts too. Shortcuts in math. Is there a shortcut to this? Well, I put the z equation here, right? Can I get this equation if I set y equal to 0? So when it comes to find the volume of the tetrahedron, do you agree I can solve for z here, and then set z equal to 0 and solve for y, put that there, and then set y and z equal to 0 and solve for x here, and then put 0, 0, 0. Wouldn't that always work? With any tetrahedron in the first octave. If you like patterns. I just want to say that again. You go, could I do this like with numerous problems where you say find the volume of the region in the first octave bounded by the plane and these coordinate planes. Then a fast way to set these up is to say, here I solve for z, right? 0. Here, let z equal 0, solve for the letter y. And then here, let z and y equal 0 and solve for the letter x. And you should get the same thing. Cool? Is that okay with that? Nice. Alright, we're going to do a problem like this, and we'll work out all the math, but we're going to find the mass. The mass of a three-dimensional object. Kind of like this. Of a solid. So what's the equation for finding mass? Now this is mass of a lambda. So what would be center of mass of a solid? Oh boy. What would be center of mass of a solid? And we'll say this is in 15.7, right? Well, that'll be an x bar, comma y bar, and then a z bar, right? Let's start with mass. What would mass be? It should be similar to this, except it's going to be a triple integral. What will mass equal to? Triple integral? Let's just call this region what? You know, whatever this is over. Let's just say it was over like region M. Row of x, y, z. dv. We use dv, v for volume. What would x bar equal to? Let's just write out, we don't have to write the y bar and the z bar. What would x bar equal? 1 over the mass times the triple integral of what letter? Kind of like this. What would be the letter? X, they call this the moment about the yz plane. 1 over mass times the moment about the yz plane. There goes that letter x. dv, this would have that same region. I should use a different letter. Let's use z. Let's say E is the actual solid. So I'm going to say for solid E. And when you're done for solid E, we'll just put over the triple integral V there. Cool. Hey, similarly, what would z bar equal? I don't even have to write out. What would z bar equal? 1 over mass times triple integral what variable? Z, and then the row of x, y, and z, right? Cool. What would y bar equal?
Same thing.
1 over mass times triple integral z times the row of x, y, and z. This would give you the center of mass of a solid. People are talking about in their statics course, they find centroids, right? Centroid is a center mass if the density is a constant. If the density is a constant. We've noticed today we got densities that weren't constant. Remember the one before? It was like the row of 1 over square root of x squared plus y squared. Well, that's not constant. But a centroid is finding is a center of mass if the density is constant. Well, let's look at a problem like that. So here you go. This one will solve though. So can you find the mass? Of the solid tetrahedron. This is in the first octave. 0, and it's got a 0, 0, 2, and it's got 0, 2, 0, and it's got also 0, 0, 2. Well, can you help me draw that? What would that look like? I'm also going to have to give you the density. So I thought, no problem. How about the density is x squared? So the density is given as x squared. Find the mass of the solid tetrahedron with coordinates 0, 0, 0, 0, 2, 0, 2. All right, let's plot this. 2, 2, 2. And it's bounded also by the coordinate planes. This is that other edge. So everything's bounded by the coordinate planes here. Okay. Well, we don't need volume. We need the mass. So a triple interval of 1 would give me what?
Volume.
Volume. We're getting triple integral of for mass. We gotta put the density there. But they gotta give you the density. The density was what? X squared. All right, let me get that right here. Here's x squared. This isn't volume. We're getting mass. Okay. And when you okay if I do dz dy dx? Cool. Here's the biggest challenge. They didn't give me an equation at plane. Like the last problem. Ugh. But I think it should be easier when they gave us easy points. What was it? This is 2, this is 2, this is 2. You know what the equation of plane is? It's rather easy. X plus y plus z equals 2. I'll let you check it. Do all those points fall in that plane? They did, by the way, I'm taking this problem in the book, they did this on purpose. They didn't want you to have to sit there and struggle to get the equation of plane. Now, if you're like, what would you do if they just gave you 3 goofy points on those x, y, and z axes? You'd have to go all the way back to section 12.5. We had to get equations of planes. You remember that? You needed a normal vector, remember? But this, it's easy to see that the equation of plane would be x plus y plus z equals 2. Notice you can plug all these points. You know, this point isn't on that plane now. The 0, 0, 0 is, you know, one of the vertices of the tetrahedron. I'm talking about the plane right here. This triangle right here, this face. But you'll notice this point, and this point are all on that face. Cool. Hey, by the way, what if they did 3? What if they did 0, 0, 3, 0, 3, 0, and 0, 0, 3? What would be the equation of plane? Of that plane right there. X plus y plus z equals 3. Your problem set, number 15, has 0, 0, 0 as a point of the tetrahedron, but then it has 0, 0, 1, 0, 1, 0, and 0, 0, 1. What would be this equation? X plus y plus z equals 1. Okay. So, and we got to set this up. What's the top z? What's your top surface? Because we're going to project this right onto the xy plane. What's that z equals? 2 minus x minus y. What's the bottom surface? 0, because it's going to be above the xy plane, right? Now here's the hard part, which I hope you find easy. Give me that projection. See, I'm projecting this onto the xy plane. Well, let me draw that again. Here, draw it. I like to draw the projection again. What's the projection look like? Projection is like a shadow, how that projects you right onto the xy plane. Projection onto xy plane, and then we'll solve this problem. It might take up a lot of room in your notes, but that's okay because it is a triple integral and we're solving it. That's a 2, that's a 2. What's the equation of that line? 2 minus x is the equation of that line right there. What's the bottom limit? And these have to be numbers. Remember, the outer limit always has to be numbers. What's the 2x values? 0 to 2. Is that okay with the 7? Hey, by the way, would the shortcut work there? That is a tetrahedron. The tetrahedron shortcut works, doesn't it? Solve for z. Let z equal 0. Solve for y. Let z and y equal 0. Solve for x. 0, 0, 0. And we'll solve this. Hey, keep in mind, we're not finding volume, are we? Volume would have been easier. What would have been here? Just a 1. That would have given me nothing. We're finding max. All right, so here we go. Can I erase this projection? All right, let's get to work. When I might run out of room here, because it's a triple integral. So I'll start over here. What's the integral of x squared with respect to z? Cool, x squared z. What are you going to plug into it? 2 minus x minus y and a 0? Hey, we got it down to 2 double integrals. I'll get out of the way once you can see this. I'm just going to go here. Bring it x squared times 2 minus x minus y, and then you subtract the 0. Cool, we're down to double integral. Well, is everyone okay with that? Cool. Now you know why I didn't give you a density z squared. Because then we would have done what? Z cubed over 3? And it became nasty, right? Do you follow me? Now you notice some of these problems it's appropriate to pull out a CAS. Do you know what I mean by a CAS? Computer algebra system? Please, by the way, please feel free to explore that on the internet. You know, you could just go, finding what? Evaluating triple integrals. There are applets to do that for you. You can check them. You follow me? Because the TI-84 is not going to check this for you, is it? But the Inspire will do it, the TI-89. I have to make sure we don't make any errors. All right, now, how do I do this integral? I can't split it up. Should I distribute? Mm-hmm. All right, let's distribute. Oh, you're the best. That's an x squared. And I'm distribute that x squared. Thank you. What's that? 2x squared minus
X cubed.
X cubed minus
XY.
x squared y. I'm just going to stay alphabetical order to stay organized. All right, and we got to integrate all those 3 portions with respect to what letter?
Y.
Y.